So hello everyone, in this video we will discuss another lead code question, that is subsets. So let us read the problem statement. So given an array, integer array nums of unique elements, we need to return all the possible subsets or the power sets, and the solution set must not contain any duplicate subset, and we need to return the solution in any order. So it is the basic straightforward question. For a particular array we need to just get its subset and return that subsets. Also, there should be no duplicate subset, and the additional information given is all the elements are unique. So looking at the time constraints, we can definitely solve with the backtracking approach, and there is also another approach using bit manipulation. So today we will discuss both of these approaches, using backtracking and then using bit manipulation. So let us see this first example to derive both the type of solution using backtracking and then bit manipulation. So this is the first example that they have given, and we need to derive subsets of it. So what all can be the subset? One can be the empty subset, one can be the single element alone, 2, then other can be 3, then we can have 2 elements inside one single subset, so 1, 2, then 1, 3, and 2, 3, and then all elements together, that is 1, 2, 3. So in total there are 8 subset for this particular array nums, and we know that for if an array contains n elements, there can be total of 2 to the power n subsets. So here n is 3, so we can have 8 subset, and we have also 8 subsets. This is 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 total subsets possible, and let us see how to derive it. So first we will use the backtracking approach and derive the solution for it, and then we will see the bit manipulation approach. So first we will see the backtracking. So in the previous video we have also seen how to derive it using backtracking. So let us see it again. So this is the array that they have given, and how do we derive a particular subset? So let's say if we are standing at 1, so if it should be in our subset or it should not be in our subset. So there are two conditions: if this particular number is in our subset or it is not in our subset. So basically there are two conditions to see. One is take, either we take that element, or the second is we not take that element. So if we are standing at 1, we can say, let's say we take this one. So we have taken this one, then we came to 2. Now if we are standing at 2, we have again two options: either we can take that or not take that. So we decided to not take that. Then we came to 3. Again we have two choices: take or not take. We decided to not take. So if we not take 3, we reach to the end of the array. That means after reaching to the end of the array, we derive one particular subset. So we'll add it to our answer. Now again we'll go back to 1. So we are not again going back, actually it is backtracking. So it will check the second condition, or it will backtrack for the further recursion calls. So it will keep on happening by taking one condition, not taking that condition, so on and so forth. We'll see that in the code. We are not actually going back. It's just the backtracking that is going to happen. So we are again at 1. So we decided to not take it. Then we came to 2. We decided to take it. Then we came to 3. We decided to not take it. Then we reached the end of the array. That means we get one subset. So this is also one subset. So let us see one example where we can get two subsets, like a subset which is containing 2 elements. So let us see that first. So if we are standing at 1, we decided to take that element. So we have 1 in our subset. Then we came to 2. We decided to not take that 2. Then we came to 3. We decided to take that 3. And in the end, we reached the end of the array. So that means this is one particular subset. So on and so forth. By these two conditions, take and not take, we can generate all the subsets. Now, how do we write this take and not take condition in our code? So let us see this first. So I am just explaining this backtracking approach in short, because we have already discussed in his previous video, so no point of taking it too long. So if you have not watched that video, so do check that out and then see this video. So in the backtracking, like we have here two approaches, two cases: take or not take. Let us say that we are doing backtracking with the help of some function sol. So with the help of sol function, we are doing a backtrack. So in the take approach, what we need to do, if we are taking a particular element, let's say this array is nums, and we are generating subsets in the res kind of vector, and the overall subset is stored in answer variable, answer matrix. So it is a 2D matrix which it contains all the subsets, and this is a particular vector which contains which keeps one particular subset. So if we want to take a particular element from nums, we will push that into res first. We are talking about this take condition. So res dot push back the current element. Current element we are iterating with the help of I pointer. So push back nums of I. Then we will move forward by taking this element. So sol we are doing with the help of sol function backtracking. So it will increment our I. Now if we are not taking this particular element, we don't need to write this condition. We just directly need to go ahead. So we will directly write this sol of I plus 1. And what will be the base condition? So the base condition will be, let me erase this. So for the base condition, what we have seen, if we reach the end of the array. So if our I pointer is greater than equal to nums dot size, that means we have already generated one subset, that is res, and we need to now push this subset into our answer. So we will push that res into our answer. And there are no further calls, so we need to return. So this is the base condition and two conditions by which we can generate subset, that is take and not take. So this was about the backtracking approach. So let us first write the code of it, and then we will see the bit manipulation approach for this question. So n is the size of nums array, and we will generate a vector of int res which will store the current subset, and we will declare a 2D matrix called answer which will store all the subsets. And then we will do the backtracking with the help of this sol function, and in the end we will return this answer matrix which will contain all the subset for this particular array nums. So we'll pass on the nums. We will have one iterating pointer which will iterate through the entire array. First it will start with 0 position or the index 0, and it will keep on going. Then we will have res, and then we will have answer. So let us write this sol function. Then we are iterating with the help of I. Then we have res, and then we have so what was the first thing? First thing is the base condition. So if I is greater than equal to nums dot size, then we need to push the current subset into our answer matrix. And what is the current subset? It is the res, and then we need to return. Otherwise we have two conditions, not take and take. So first we'll write the not take condition. So in the not take condition, it is simple. We just need to move forward without considering a particular element. So we'll just increment our I pointer, and the rest all things remain same. Now if we are taking that element, first we need to push that into our res vector. So we'll push back the current number or the current value to our res, and then we will move forward. So it will be I plus 1, res and answer. The things remain same. So let us see again what is happening. So first we have declared the size of array. This will store the current subset. This will store all the subset. Then we are doing backtracking with the help of solve function. So in the solve function, first we have the base case. If we reach the end of the array, that means we generated one particular subset. So we'll push that into our answer and then return. Now we have two conditions. If we want to take a particular element or we don't want to take that particular element. If we don't want to take that particular element, simply move forward. If we want to take that particular element, push that into our res vector and then move forward. So this is about this. So let us see if this works on sample test case or not. So it works fine. Let us see if it gets submitted. So yeah, our code got accepted, and this was one of the approach, and we will see another approach using bit manipulation. So let me erase this. Now we'll see the bit manipulation approach using like how we can solve this question using bit manipulation. So in the bit manipulation, what we are doing is we are considering all the two conditions as a bit. So in the backtracking, we have two conditions, take and not take. So we have only two scenarios, take or not take. So we can consider this as binary conditions. Either we take means 1, or we don't take means 0. So for each of the like element in the like this array, we have two conditions. Either we can take it or not take it. Take it means 1, not take it means 0. So we can generate all possible scenarios with this. So let us see one by one all the examples for this. So first can be we don't take any element. Then we can say that we take this one particular element, and like I'm just writing it for a while and then I'll explain you what I'm doing. So let us see till now here what we are doing. So this particular bits, if it is 0, that means we are not taking a particular index element. If it is set, that means we are taking a particular index element. So we have 0, 0, 1. So it is at position 0, it is at position 1, and it is at position 2. So if position 0 is set, that means we need to, so this is the indexing of the array. So position means the index of the array. So if a particular position is set, that means we need to take that index element. So here 0th position is set. So we need to take the 0 element into our subset. So what is the 0 element? 0 element is nothing but 1. Then it is 0 at the first position and 0 at the second position. That means we don't have to take that element at the first position or first index and element at the second index. So we'll not take 2 and 3, and this is one particular subset that we have generated. Similarly, we have 0, 1, 0. It is the 0th position, first position and second position. So at position 0, we have 0. So there can be two possible scenarios, 1 or 0. 1 means we need to take that element at that particular position. 0 means we don't have to take that element at that particular position. So at position 0, we find 0. So we don't have to take element present at index 0. What is at index 0? At index 0, we have 1. So we don't have to take that. Then we are at position 1. So we see that position 1 is set. So we need to take element present at index 1. So what is that element present at index 1? It is 2. So we'll generate another subset which will contain 2 till now. Then we came to like position 2. So the at position 2, the like bit is 0. So that means we don't have to take element that is present at index 2. What is present at index 2? It is 3. So we don't have to take that. So after that, we reach the end of this entire bit. So we'll generate another subset, and so on and so forth. We will generate all the possible subset. So let me generate all the possible subset, and then I'll again show you in a more better way. So I have written the all possible scenarios which are possible for this array nums. So these are all the scenarios, and let us see how we can generate subset with using these bits. So in the first case, all are 0, that means it is an empty subset. Now in the second case, this one we have one bit set, and that is at index 0. Now you don't see this index for these bits, like these bits start with indexing from here, and in this array it starts from here. So don't confuse with this index represents the index for the array nums, not for these bits. The bit indexing or the bit position start always from right. So in the second case, the 0th position is set and all other are 0. So we need to consider element present at index 0. So at index 0 we have 1. So we will take 1 into our subset. Then in the second case, the 1 bit is set, that is at position 1. So we need to take the index 1 element. So index 1 element is 2. Then we need to we have this case where the second position bit is set. So second position, so that means second index in this nums. So at second index we have 3 in our array nums. So we will take that 3 into our subset. Then comes the this case. So here we have 2 bit set. One is the at position 0, other is the at position 1. So what is the element present at index 0 and index 1? We need to take that. So it is 1 and 2. So we will take 1, 2. Then we have a bit set at position 1 and position 2. That means we need to take element at index 1 and index 2. That is 2, 3. Then we have the case where we have position 2 set and position 0 set. That means we need to take element at index 0 and index 2. So we need to take 1, 3. And then we have all bit set. That means we need to take all elements into our subset. So these are all the 8 possible subset that we have generated using this bit manipulation technique. So you can see that these are all the correct subset that we have generated using this bit manipulation. So this is another approach by which we can generate all the possible subset for a particular array nums. So what how will we do it? How will we actually code it? We have understood in a by drawing perspective, we can say that okay, if this bit is set, then we will take that element. If this bit is set, then we'll take this particular element. But how will we code it? So let us understand now. So let us see how we'll do it. So we have we'll first run a loop of I, which will go from 0 to 2 to the power n. Now why we are running this loop from 0 to 2 to the power n? Because we can have 2 to the power n subset. And what are all these? How we are representing those subset? In the form of bit. So first can be 0, 1, 2, 4, and it will cover all the numbers from 0 to 2 to the power n, that is in this case 8. So it will go from 0 to 7. And you can also see that all the numbers from 0 to 7 are present using this bit representation. So here we have 0 and the last one is 7. So we can't have bigger than 7, we can't have lesser than 0. So we are first running a loop from 0 to 2 to the power n, less than 2 to the power n. So this I represents a particular number like this 0, 0, 0, 0, 0, 1, 0, 2, 0, 1, 0, and so on and so forth. Now for each and every I, what we are doing, we need to check each and every position of that bit. So how many positions can be possible? Obviously, if you can see, there are 3 elements, so there can be 3 possible positions. So for n numbers, there can be n possible positions. So we'll again run a for loop for all the positions which we will check for I. So j will be running from 0 to less than n. Now what we need to do is, for each and every number, this number is represented using I, this is represented using I. So let us say we have first 0, 0, 1. Actually it will be 0, 0, 0, but let's say we are checking the case for 0, 0, 1. So I is currently 0, 0, 1. Now for this I, we need to check each and every position. For that we are using this j loop, which will check each and every position. Now we need to check if this particular position is set or not. So for that we will write if I and this. So what is this? It is checking if this jth position in this I is set or not. If it is set, that means the number present at this index, we need to take it into our subset. So we need to push that number into our res. So we'll push back that number. And what is that number? That is nums of j. Why j? Why not I? Because I is the entire number, j is the position of that particular bit which is set, and we need to take the element present at this particular position in the array nums. So that's why we have written j. Now this will continue for each and every I, and for each and every I it will check each and every position, and if it is 1 it will push that particular index number, otherwise it will not. And in the end we are just pushing that res into our answer matrix. So this is how it will be done. Let us write the code now and understand in more clear way. So let us declare the size of the array, that is n. So what we are doing first we need to declare the res and answer matrix or answer vectors. So res will store the current subset and answer will store all the subsets. Now what we are doing, we need to loop I from 0 to 2 to the power n. 0 to I less than 2 to the power n. This is nothing but this is 2 to the power n only. I have written in bit format, bit manipulation or bit operation format. Then for each and every I, what we are doing, we don't need to create it here, sorry for that. We are creating a vector which will store the subset for this particular bit arrangement. So we have 0 0 0 0 0 1. So for, let's say we are at 0 0 1. So for that 0 0 1 we'll generate one particular subset. For 0 0 0 we'll generate one particular subset. So this will store that particular subset. Now what we need to do is we need to check each and every position of that particular I number. So what we have seen, if this one, so if this particular position in I is set, if this particular position is I is set, that means we need to take that position element from our array nums. So we'll push back nums of j into our res. And after that, when we have checked each and every position, we need to, that means we have generated one particular subset and we need to push back into our answer. So we are pushing that res into our answer matrix, and this will keep on going for each and every number from 0 to less than 8. And for each and every number we are checking each and every position. If that particular position is set, then we need to take that element present at that particular position from our array nums, and then we are pushing that into our res. After checking all the positions, we are pushing that subset into our final answer, and in the end we are returning that answer. So let us see if it works or not. So it works fine. Let us try to submit it. So our code got accepted. Hope you learned from this video. Thank you.